In the triangle ABC, so ABC, AB is equal to AC. So AB is equal to AC. And BE is perpendicular to AC. So BE is perpendicular to AC. So we have a right angle here and here. Part 1. Use Pythagoras' theorem to show that BE squared is equal to 2 times AE times EC plus EC squared. So we're going to consider the triangle ABE. ABE. In which AB is equal to AC. So AB is equal to AC. So, using Pythagoras' theorem, which states that c squared is equal to a squared plus b squared, where c squared is the longest side, the hypotenuse, we're going to have BE squared plus AE squared is equal to AB squared. So AB is the hypotenuse. So AB squared is equal to BE squared plus AE squared. So BE squared plus AE squared is equal to AB squared. So we're going to bring the AE squared over the equal sign. It becomes minus AE squared. So we have BE squared equals AC squared minus AE squared. Now we know that AC is actually AE plus EC. So AC goes from the top right to the bottom is actually AE plus EC. So AC is AE plus EC, and that's squared. And make sure you've got brackets around both of these. So we've got BE squared is equal to AE plus EC squared minus AE squared. Then we multiply out AE plus EC squared. We're going to have AE squared plus 2 times AE times EC plus EC squared. And then we bring down the minus AE squared. So this multiplies out to this. Then the AE squared and the minus AE squared will cancel. And we bring down the 2 times AE times EC and the EC squared. And we're left with BE squared is equal to 2 times AE times EC plus EC squared. And this is what we were asked to show. Part 2. Hence or otherwise show that BC squared is equal to 2 times AB times EC. So we're going to consider the triangle BCE. So BCE, so the smaller triangle. So by Pythagoras' theorem, we have BC squared is equal to BE squared plus EC squared. So BC is the hypotenuse. So it's going to be BC squared is equal to BE squared plus EC squared. So BC squared is equal to BE squared plus EC squared. Now, in part 1, we showed that BE squared is equal to 2 times AE times EC plus EC squared. So we swap the BE squared for 2 times AE times EC plus EC squared. And we bring down the plus EC squared. So we have BC squared is equal to 2 times AE times EC plus EC squared plus EC squared. EC squared plus EC squared becomes 2 EC squared. So we just add them together. So on the right hand side of the equals we have two terms. We have 2 times AE times EC, and then we have 2 EC squared. So we have two terms and we're going to factorize them. So we notice we have a 2 in front of both of them. So 2 is going to be part of our HCF, our highest common factor. And we know that EC is common to both of them as well. So 2EC is going to be our HCF, our highest common factor. So the 2 will cancel with the 2, and the EC will cancel with the EC, and we're left with AE inside the bracket. And then the 2 will cancel with the 2, and the EC will go into the EC squared and leave us with EC. So we have BC squared is equal to 2 EC times AE plus EC. Now we know that AE plus EC is the same thing as AC. So AE and EC is the same as AC. So AE plus EC is equal to AC. So AE plus EC is equal to AC. So we have BC squared is equal to 2 times EC times AC. And we know that AC is equal to AB because it's an isosceles triangle. So AC is equal to AB. The length is the same. So we swap the AC for AB and we bring down the EC. So we get BC squared is equal to 2 times AB times EC. And this is what we were asked to prove.